The Woodworks BC program, in conjunction with the Canadian Wood Council, is working proactively in supporting those within the design community that have solutions to the design of 6-story wood-framed buildings. It supports and encourages those that are looking at traditional wood-framed as well as composite interpretations and the creation of new and innovative developments of wood products not yet used. Through constructive dialogue, we believe sound and cost-effective wood solutions are out there and will be found.
Hello, I'm Suk Johel and this is Stephen Street. We're both technical advisors for the Canadian Wood Council. I'm here today representing Woodworks BC.
And I'm representing Woodworks from Ontario.
As you're aware, as of April 6th, the BC Building Code will be amended to allow for up to 6 stories of wood frame construction for residential buildings only. The question many have is, what would these buildings look like and how will they be designed? Luckily for us, our neighbors to the south, here in the Seattle area, have been building mid-rise for the past 6 to 9 years.
We have an exciting opportunity in the next couple of hours to actually tour some of these buildings and to have a little bit of an insight into how they're built structurally and aesthetics and what they look like.
Lake City Court Apartments is another 6-story wood frame building. Its use is mixed. Once complete, it will hold 76 units of low-income disabled housing, and a food bank and medical clinic will be situated on the first and second floors. The building is situated on grade with a second-level concrete deck and 5 levels of wood framing. The project consists of 5 stories of Type 5A wood frame construction above 1 story of Type 1 concrete construction and will be fully sprinklered to NFPA 13 guidelines. The first level is a shared commercial tenant space with 28 parking spaces both inside and outside. The second level is also a shared space with a clinic and common residential tenant space.
Well, as soon as you come into this Lake City apartment building, you're met by the elevator shaft, and what's really interesting is below me is the first level of concrete. This is the temporary platform for the safety during construction, but you're met by this wooden elevator shaft, which is very different from how we do it. The wooden shaft, it reaches up the full 5 stories through the building, and they line the shaft with 2 layers of drywall, which gives them the full 2-hour fire rating which they need.
The low-income housing use of this building resulted in very Spartan rooms being only 13 feet wide. The design much like that of a hotel room, but it does allow us to demonstrate platform framing in its most simplistic manner.
Okay, now let's look at platform framing. Platform framing incorporates both non-bearing and bearing walls. On the structural aspect, we have both 2x4 bearing walls. In this particular case, it's a party wall where we have staggered studs on a 2x6 plate. 2x6 exterior walls, and this is also copied on the corridor walls. The thicker studs allow for increased insulation to protect the unit from, obviously, outside temperatures, be it hot or cold. There's also strategic placement of studs, and this is a bearing column, which is used to support the transfer of loads from the glulam beam above. The floor system. Now these can be dimensional lumber, I-joists, or open web 4x2s. In this particular case, the engineer chose to go with 9.5-inch I-joists. The main function of the I-joist is to transfer both the dead and live loads that are applied to the floors up above. The I-joist then transfers the loads to the bearing walls. The bearing walls then transfer down to the concrete foundation. Now, that takes care of static loading. Now we have to take a look at dynamic. Dynamic, it takes care of the external forces that are applied on the building. There are 2 forces, either wind or seismic. And as we move up higher to 6th story, depending on the location, wind will most likely govern. Shear walls are designed, obviously, to resist those loads, and the use of plywood instead of drywall is used to counter those forces. Now, of course, as we move higher, the tendency for floors 5 and 6 will have greater horizontal drift. Now, how do we address this? And this is where continuous tie rod systems come in. To further discuss the continuous rod system, I have with me Ed Chin, a professional engineer from Earthbound Corporation. Ed, can you tell us more about your system?
Sure. As you talked about the shear wall before, Basically, a shear wall is a lateral force resisting element for building, and one thing we have to be concerned about is how do we contain the overturning of a single shear wall. Well, in this particular mid-rise stacked building, we use a continuous rod system. So basically, this rod extends from the foundation, which is below this level, and goes all the way up to the top level of this building. So one consideration to worry about in a rod system is wood shrinkage and the effects of how tight that connection is going to be when a seismic event occurs. So how we solve the system in this particular instance is that we have a device here, basically on top of this bearing plate, which is containing the differential load of the level below us. We're basically in the second level, so this is the first occurrence of the device. So how this device is actuated is basically it's spring-loaded, and as the building shrinks, this device travels with the building to make sure there's no gaps between the nut and the bearing plate during an event. In the six-story building, as far as shrinkage is concerned, if you use standard 2x12 joists, you could probably expect almost 2 inches as you work your way up, because shrinkage is cumulative from the ground floor all the way up to the sixth story. So the shrinkage increases as you work your way up. So at the sixth story, you probably could almost see 2 inches.
And if you use I-joists?
It'd be substantially reduced. You'd probably total shrinkage probably be in the range of, inch and a quarter.
And the capacity of your take-up devices?
We do have a 3-inch travel part that we would put on the sixth story. This particular application is 1-inch travel device, because since we're on the second floor level, there's only one floor system worth of shrinkage, so maybe a quarter inch of shrinkage at most, and we have a 1-inch travel part here. So what I want to show you now is how a run typically terminates the top story of a building. So basically we're at the fifth level of this wood structure, and I have a 2-inch travel component, and it's on top of a patented bridge connection, which is a part of the rod system. So basically, this bridge and these trimmers are all specified by us as integral of tying the top story of the building to the rest of the structure.
The structural roof system that they employed here is open web tapered trusses. Trusses are essentially 2x4s or 2x6 dimensional material connected with metal connector plates. Trusses have been found to be the most efficient form of structural roof framing, and there are also many different applications for trusses. Here, for example, is a shear panel block that is used to transfer the forces from the roof diaphragm to the corridor walls. In this particular case, the engineer decided to extend the top cords into the corridor to provide the ridge for the roof system, but also trusses can be designed much longer, 66 to almost 90 feet, depending on the application.
Low-income housing is just one example of how wood-framed construction is changing the landscape of Seattle. High-end units are where engineered wood products really excel. This complex, the Marcel Condominium Project, has just been completed, but let's take a look at one still under construction. Located in the affluent neighborhood of Bellevue, Washington, is the 318,000 square foot Belle Kara project. This group of 6-story wood frame buildings include 296 luxury apartment units and over 15,000 square feet of leased office and retail space. Hidden among this concrete jungle, the developers chose to build with wood. Inside, we see the meticulous attention to detail. Extensive use of engineered wood products maximized the designer's option to provide dynamic, multi-purpose open areas. The spacious units are all 25 to 32 feet wide, and many on the upper floor units have penthouse mezzanines.